We are now going to go through a goodness of fit test, and we're going to take something that's a little bit fun. You can do this at home. You can purchase a bag of peanut M&Ms or any particular candies with M&Ms, and we are going to determine if the percent distribution of the colors is exactly the same as the percent distribution that the manufacturer suggested should be. So let's check this out. According to the manufacturer of M&Ms, 12% of peanut M&Ms in a bag should be brown. 15% are yellow, 12% red, 23% blue, 23% orange, and 15% are green. A student randomly selected a bag of peanut M&Ms. He counted the number of M&Ms that were each color and obtained the results shown in this particular table below. We want to test whether peanut M&Ms follows the distribution stated by M&Ms at a 5% level of significance. Well, let's see. We have the colors, we have the percent distribution as stated by the manufacturer, and we have the frequency of the colors as they appeared in that bag. So the very first thing we want to be able to determine is how many do we expect according to the frequency, the percent distribution. So the very first thing we have to determine is what's the sample size. So in order to get the sample size, what we're going to do is we're going to calculate the sum of these particular numbers. We're going to take the sum of the column, and we go through this entire column, and that tells us there were 400 M&Ms in that particular package. Now we're going to use the expected value formula, which says that E is equal to the N times the P, basically the number of M&Ms times the percent that we anticipated. So for the expected number, in order to be able to form this formula only once, we are going to take the number of M&Ms, which is 400, press F4, in other words, make it a fixed cell, times the percent. So we would have expected 48 of the M&Ms in this bag to be brown. Now, we're going to copy this formula. So remember, we left click, make sure we have the plus sign on the bottom right-hand corner, and we go through all of the M&M colors. So we would have expected 60 yellow, 48 red, 92 both orange and blue, and finally 60 green. Well, now that we have the observed value, which is our frequency, and the expected value, which we calculated, we're going to go set up our hypothesis test. And what we're going to say is the distribution, distribute would help if I could spell, of M and M's is the same as stated by the manufacturer. The alternative says that the distribution of M&Ms is different than stated by the manufacturer. Well, now we're ready to be able to determine the p-value because the chi-square test gives us the p-value. So we have that information, and we're going to figure it out. And again, check my spelling. So we go to formulas, we go to statistical, and we're going to go to chi-square test. And the only thing we have to put down is the actual range, the expected range, and we have the chi-square value of 0.613025. Well, now we're going to come to the next step. Is what are we going to do? We're going to compare the p-value to our given alpha. And let's make it look pretty. And there's our alpha. So we're going to put it down. So let's see what we have. Our p-value, remember, is exactly the same as the chi-square test value. And the alpha is the number we are given in our paragraph. So our alpha is 0.05. And we take a look, and again, I would like to be able to make that comparison. I would like the same number of decimal digits, and that looks good enough. So it looks like the p-value is greater than the alpha, and again, we're going to pretty it up, put this in the middle, and now we can draw our conclusion. And for our conclusion, we can say that since the p-value is greater than our alpha, the results are not significant. Therefore, we do not reject the null hypothesis, which means we believe that the percent distribution of the color of the peanut M&Ms are as stated by the manufacturer.